Hi, in this video, we want to take a look at plotting maps using ggplot. All right, so ggplot is a major, powerful workhorse for data visualization in R. And what we want to do, we want to grab all those powers, all the features of ggplot, and use them specifically for plotting maps. Now, how we're going to approach this is that we're going to represent boundaries, islands, countries, things like that, using a polygon, the polygon geom in ggplot. So what we need to do, we need to get the points that define the boundary. Then we're going to use the geom polygon function to draw a line that gives us the actual boundary, and we'll plot the boundary that we are interested in. Okay, so now something about plotting maps is that there's a lot of different data types for storing things within maps, and all of them have a little bit of nuance to them that you have to be ready for. I feel like this is the simplest approach, is just using straight polygons, and we'll go ahead and start digging into this. Now, what I've got here is blatantly copied and pasted from Hadley Wickham's website and Hadley Wickham's book. Now, I modified it a little bit here and there, but if you go and look at his book, if you go and look at his website on GitHub, you'll see that I'm staying pretty true to what he's got going on. If you read the actual text in here, you'll see like the word I in there. That's Hadley referring to himself. That's not me. I deserve none of the credit. All right, so when we are creating maps, for the purpose of data science, we usually have like two specific things that we need to do. First and foremost, we need to get a source for the data for the map as a whole, and then we start pulling in information and putting it on top of that map. Okay, so the first part, we need to get things like boundaries and geographic information, things like shorelines, roads, things like that. We need data sources for this, and there's no shortage of sources out there. Now, here are some major ones, some very common ones that you can work with. Some are very easy to work with while you're using R. So here, the U.S. boundaries package in R gives us boundaries of different states at different times in the country's history. The Tigris package gives us census information. So here, this is giving us the census shapefiles so that we can see where are the census regions. And our natural earth package, it bundles up the free high quality data from naturalearth.com. It contains country boundaries and borders from the top level region of each country. So for like states and regions and prefectures, things like that. And the OSMAR package, this pulls in the OpenStreetMap API for us very nicely. Now, something to be mindful of whenever using an API, anytime you're looking at documentation on a book, a website, YouTube video, realize that that website is free to change any aspect of its API requirements at any time. So always remember, when you start using a package like this, like OSMAR, the API requirements may have changed since that was published, and you have to just kind of work through it to figure out if you can get things going. This happened to me when I was buying my house and I was pulling stuff from Zillow. Now, shapefiles, if you have a particular shapefile of your own, of course you can read it with the SF package with read SF. So it's simple formatting. So for me, my experience with these types of files usually comes from school districts. I say, hey, I need your school district because I'm going to plot it. I'm asking for public records. I want your school district boundaries. Boom, I get it, and I can do my mapping. All right, so let's go ahead, and the next couple of videos are going to tackle some particular problems. First one we're going to talk about are Polygon Maps, where we're using geom polygon. And then after that, we're going to look at simple features, SF, with geom simple features. Then we'll look at map projections. All right, now this is important when we start looking at larger regions to worry about, because remember, the Earth is not flat, but we are representing it with a flat surface. So there's always some information lost, even if it's at a tiny scale. Also, this part will address aspects like, what if I want to plot the North Pole, South Pole? Because the standard way of the Mercator projection does not really do well for Antarctica. And then we'll also look at raster maps. And these videos, I'm going to be largely using Hadley Wickham's book to guide me on this. All right, so Polygon Maps. This is, I feel, the simplest way to start getting a map down on paper. And that's why I'm starting out with this. All right, so what we're going to do, we're going to have a bunch of dots that correspond to latitude and longitude of part of a boundary. And then we're going to go through and we're going to play connect the dots with the geom polygon function. And by doing connect the dots, we'll be able to see what are the different regions of an area on the Earth. And the map data function in ggplot2 gives us a bunch of data sets nicely for us. So that if I want standard data to grab onto, I can just go do it. So the map data function usually has more well-established information. So things like school districts, don't be looking there for it. More nuanced information probably is not going to be available. Now, I am making this video for a University of Central Florida course, so I'm going to be focusing on Florida quite a bit. Go Knights, charge on. All right, so we're going to pull in some Florida data, and we're just going to take a look at what we get while building some maps. All right, so I'm going to use ggplot2, and I'm going to be doing some piping, so I go ahead and pull in the McGritter package. And the reason why I'm going about everything this way is because this is how Hadley wrote it. Therefore, I'm following him pretty closely. All right, so map data in the ggplot2 package, I'm going to say, hey, I want county maps for Florida. Then what I'm going to do, I'm going to reduce down the data set to just latitude, longitude, group, and ID. Okay. Now, subregion is going to be county for this purpose. And group is going to be a number that corresponds to each county. Now, when I looked at it, group look for my cursory look, it looks like group goes from 1 to 60 something, 67, and it looks like they're in alphabetical order. So Alachua County, you're number 1. All right, so let's go ahead and take a look at what we've got for the data. So we have the longitude, the latitude, the grouping, and then the ID or the county. Now, colloquially, we always say latitude and longitude. But if you look at the coordinate system, you'll notice that longitude corresponds to the east-west horizontal position on the standard progression, while latitude corresponds to north-south, the vertical direction on the standard projection. Therefore, in mathematics, we like to put longitude first. So how I always remember this, it's always backwards of alphabetical order. Longitude is my X and Y, my X axis. Latitude is my Y axis. Okay, so now just to kind of give you a feel for what this data set looks like, I've shown you each of these is a point on the XY plane that is a dot on the county boundary of Alachua County. Now, what I could do, I could try and go, hey, I want to summarize this, to make it a little bit easier for me to understand. In this block of code, and this is not in Hadley's book, but I'm sure he would approve, I'm going to go through, I'm going to group by each of the counties, and then I'm going to replace longitude with the average of the longitude for the county, the average of the latitude for the county, and I get a new data set. All right, and we can see that there are 67 counties in Florida, at least according to this data set, which I think is correct. And we have it, the top is going by alphabetical order. Okay, now here, this value, so I took an average of the longitude to get this number. I took the average of the latitude to get that number. All right, if I have a region that looks like a U, a V, a crescent moon, something like that, this average may or may not be actually in the region I'm looking at. As long as I have a relatively similar to an n-gon, a regular n-gon shape, or just a solid block, as long as I have a convex shape. If I have a convex shape, I'm guaranteed to have this point be inside the geographic region I'm interested in. Now, if you think about Hawaii, if I was to run this for Hawaii, more than likely the point I would get would be in the water. It would not actually be on one of the islands. So what's going on here is that this is computing the geographic center using the points along the boundary. Now, if I have a disparity on the points for parts of the boundary, certain parts of the boundary will have less influence on this. There's something just to be mindful of. My experience, as long as I have a convex geographic region, this is usually inside the region I'm interested in, and it's not a problem. All right, so the data has 4 variables: latitude and longitude, the county name, and then the group, which is really just, corresponds to county. All right, so just to show you what's in the actual file itself, this is not how I would make a map, but to show you what is in the file, in the data set, what I'm going to do is I'm going to take each of the latitude and longitude dots, and I'm going to plot them, and I'm going to see what does that look like. Okay, well, when I do that, here I'm using geom point. Here I've got Florida counties. I've got longitude as X, latitude as Y, and size is 0.25. And I can see that this looks like Florida, but it doesn't look like a complete representation. We can see the rivers that form boundaries of counties, and we can see the shoreline, but I don't really see much of a boundary between Alabama and Georgia. But what's going on here? I don't see what's going on for the boundary between like Seminole County and Orange County. What's up with this? Oh, now this coordinate quick map, this makes sure that I have the right ratio of my map. If I don't do this, I could have like a fat or narrow direction for my map. So this is very important for us when we are making maps. All right, now what I'm going to do, I'm taking exactly the same data set, but this time instead of dots, I'm using the geom polygon function. So what this is doing is taking those dots we're just looking at, and it's playing connect the dots. Now, it only plays connect the dots on dots that are in the same group. All right, so we can see like this is Seminole, and here we can see Orange County, we can see Brevard, we can see Osceola. These are the ones I'm most familiar with, but we can look through and see all these. All right, so over here is Brevard. How does Brevard look when I go up here? Well, I can see like the straight part, or sorry, I can see the part that's the shoreline, but when I start looking at the straight edges, what has happened is that the data set only contains like 1 point for here, 1 point for there, 1 point for here, and the straight lines are just represented by individual points. And so that's why it looks so funky in the previous map that we made. Now, something that is a common complaint when I start plotting maps of Florida, you'll notice that the Florida keys are missing. I think they are considered part of Monroe County. If you're watching the YouTube video, tell me if I'm right, tell me if I'm wrong. Now, something that's important to remember is that I use Quad Quick Map to make sure that the aspect ratio looks right. So here, this is correct. Now, what happens if I drop that? if I drop coordinate quick map, you'll notice now it looks fatter. What's doing is taking the X and Y coordinates, the longitude and latitude, and it's stretching them or compressing them all the way to the size of the plotting area, which is not what I want, because I want the ratio to be the same. So what it is doing by default, ggplot tries to fill in the entire region possible, even if that distorts the ratio of it. And the reason why this is done is to zoom in so that we can see a regular mathematical plot better. In this situation, I want the aspect ratio to be the same. So I absolutely want to include coordinate quick map. All right, so now something else that we can do, we can put points on our map or other objects to give us information about what's going on. So what I want to do now, I'm going to take from the maps package, I'm going to take US cities, and I'm going to take ones that are from Florida. Now this data set includes cities that I think are 40,000 and larger. And then I'm going to go ahead and plot this. So what I'm doing here is I'm doing some data prep. I'm getting the data. I am changing it to a tibble, just so it plays nice with the tidyverse. I filter out so that I only get Florida counties. I get rid of parts of the data that I don't need, and I change the label of long to lawn, because that's what's going on. Something that you'll notice as standard, sometimes you'll see for abbreviation LAT for latitude. That's reasonable, but longitude may be LON or LONG. Just be ready for either way. And then just to make it easier to interpret, I go ahead, I put the population in descending order. And then I go with the head function just so that we can see what's going on. All right, so now I have a tibble, and we see that Jacksonville is the largest population city in Florida. Now, when I looked at that, I was like, no, that can't be right. It has to be Miami. This is correct, and I'll show you why in a moment. If we consider Miami proper, Jacksonville is larger. I think Jacksonville proper is probably much bigger than Miami proper. Now, when most people say Miami, they mean a much larger area, probably the entire county for most people. So then after that, we have Miami, Tampa, St. Petersburg, Hialeah, and then Orlando. Go Knights. All right, so now let's go ahead and plot these cities using the latitude and longitude. Now let's do it as a scatter plot. Now this is going to look stupid, but I just want to show you how this is done, so the next thing comes up makes sense. All right, so up here is Jacksonville. Here is the Miami area. So the reason why Miami is smaller than Jacksonville is because you can see that cities that most people would consider part of Miami technically are not, and they are considered different separate cities. So here's Tallahassee, Panama City, Orlando. We can see Tampa over here. All right, so now let's do this again, but this time I'm going to take this map and I'm going to plot it on top of the county's map so I can see what's going on. And now this is much more informative. So, we have a much more precise representation of where things are. Now, something I did just to make this a little bit more interesting, I went ahead and I colored the cities by capital yes or no. You can see that the blue one, they're teal, is Tallahassee, and then the rest, the reds, are the non-capital cities in the data set. All right, now this next part, we want to go in and we want to color each of the counties by some data that we have. All right, well, to do this, I'm going to need to pull in some data. So what I did, I went ahead and just went and found population data from Stack Overflow. I literally copied and pasted this. So here's the county name. Here's the population. And I'm putting it all into a data frame here. Now, what I'm going to do is I need to, if I look at the data set that I previously got, the Florida counties data set, everything was in lowercase. So if you go back up here, you'll notice that Alachua is lowercase. Okay, so to make a correspondence between the data I just got and my Florida counties data, what I need to do, I need to have common case, I need to have matching character strings. So I go ahead and put my new data set into lowercase counties on this step right here. Now, there's something very important that I want you to be mindful of whenever you're merging data sets that involve shapefiles. Okay, remember how I said that we plot a bunch of points and then we play connect the dots. If I do anything to my data that changes the order of the rows, it will completely destroy the shape of the boundary because it has to play connect the dots in order. All right, so if I do a merge statement, more than likely, what's going to end up happening is that my data is going to get shuffled in a manner that supports merging, and so then the merge is going to mess up my shape files. Okay, so what I need to do is instead, I did things kind of a manual brute force way. I created a population column, and then I went one by one on each row of my population data set. I found the county that matches, and then I insert the number into here. This is a very inefficient way to append data onto a data set, but it works. Another option would have been to create a row index column and then merge and then resort by the index. That would have been a slicker way. Either way, it works. It's all good. All right, so now I want to go ahead and I want to create the plot. So I'm going to go through and I'm going to do the geom polygon. And I'm going to have a gray background for each boundary, for each county. And then I'm going to put in a color corresponding to the size of the population. And so if it's bright red, there's more people in that county. All right, and so here we can see that the Miami-Dade County has the largest population, and then the ones just north are larger populations also. You can see that orange has a decent size. All right, well, that's all I've got for you. Take care and goodbye.